Hi, in this series of videos we're going to be looking at GCSE Maths walkthrough. Each of the playlists is going to be about 4 or 5 videos. Each video will be about 20 minutes long. Please do stop the video, have a go at each of the questions and then compare your solutions. If you do need any help, please add a comment below. I'll always come back to you. I look forward to seeing you inside the next video. Hi, this is the third video in the playlist where we're looking at the AQA, and it's the higher tier paper 3 from June 2018. In the previous video we completed through to question number 18, so we're going to start with this at question number 19. Okay, so we've got the equation of a straight line is that, and circle the point where the line crosses the x-axis. So basically what we're saying is that the value at the x-axis is where y equals 0. So it's gone along, but it's actually not gone up anywhere. Okay, so where it crosses the x-axis is where it's gone along by 0, but it's not gone up anywhere. In other words, the value of 2y is going to be equal to 0, because 2 times nothing is nothing. So we've got 3x equals 24. If you divide that through by 3, then we're going to get x equals 8. Okay, hopefully that's all right, that you can see that it's actually going to be 8, 0. So it goes along to 8, but it doesn't go anywhere into the y, above the y line. Okay, I hope that's all right for you. Let's move on then to question number 20. Okay, now question number 20 is, it says use Pythagoras theorem. So we're going to be using that to work out the exact value of x over y. Okay, so let's have a look at how Pythagoras theorem works. Well, basically the square, in other words this squared, 10y squared, is equal to 7x squared plus x squared. So we can actually write that out, okay, as something along the line of 10y squared equals 7x squared plus x squared. Now you'll notice that I've used brackets. The reason I've done that is because it reminds me that I also need to multiply out by the 10 by a square and also the 7 by a square. So basically I can now remove those brackets, and I've got 10 squared is going to be 100y, and y squared is going to be square. Okay, so rather 10 squared is 100 and y squared is y squared. Okay, same with this, that's going to be 7 squared is 49 and x squared plus x squared. So in other words, what we're saying is that 100y squared is equal to 49x squared plus x squared is 50x squared. And really it's just a case now of manipulating this so we get x over y as the question is calling for. Okay, so what I'm going to do is I'm going to divide both sides by 50, because if I do that, then it means that on the left hand side I get 100y squared over 50, and on the right hand side I just get x squared, which is a little bit closer to what I need, because now I can divide both sides by y squared. Remember that I want x over y, so if I divide both sides by y squared, what happens is on the right hand side it cancels itself out. On the left hand side I can write this as 100 over 50 equals x squared over y squared. Okay, so it's that x over y that you're looking for, and we've just kind of got to get that y over to the bottom over here. Now I know it's not exactly there, but it's going to give us the ability then to say, well actually I've got 2, because 100 divided by 50 is 2, equals x squared over y squared. Again, not quite there, but if I square root both sides, what I actually get is the root of 2 equals x over y, because x squared over y squared rooted is going to be x over y, which is exactly what I'm looking for, and then 2, the square root of 2 is root 2. Okay, so the exact value of x over y is going to be equal to root 2. Okay, I hope that's all right for you. It does take a little bit of thinking through, but please do stop the video and kind of have a look through this if you're not sure, and see if you can work through it yourself would be great. Okay, so let's have a look then at question number 21. Okay, and this is one of those, in this particular case, it's a direct proportion. The mass of an ornament is m and the height of the ornament is h. M is directly proportional to the cube of h, and this is the bit of information that you're interested in, because if we write that mathematically, we can say that m is directly proportional to the cube of h. Now notice that it is not the cube root, it's not the cube root, it's the h cubed. Okay, so be very careful about them. This is a 3-mark question, but you could kind of do a cube root and get the wrong answer. You still get a couple of marks, but you just got to be very careful with this. Okay, so it says when m is 1600, h is 8. Well, that's all right. So 1600 equals 8 cubed. Well, actually, no, it doesn't. Okay, because there's something missing. It's only going to be correct if we've got this k, or this constant, okay, that means that I multiply 8 cubed out, and then I multiply it by k, and I'm going to get 1600. So remember that we have to balance around the equal sign. Okay, now if I divide both sides by 8 cubed, I'm going to get 1600 over 8 cubed, and that's going to give me k equals 25 over 8. Now it is a calculator question, so hopefully you'll be able to kind of manipulate that through. So actually the equation, in order to make this both sides equal, this is the statement, but we've got to make the equation. So the equation is going to be that m equals 25 over 8 times h cubed. Okay, so that k has to be put in order to make these two sides balance. And what we did is we used this bit of information in order to work out the value of k, which was 25 over 8. Okay, then it says work out the mass of an ornament of height 12 centimeters. Okay, well, I'm going to use exactly the same formula. The mass equals 25 over 8, and it's going to be multiplied by 12 cubed, isn't it? Okay, so whack that into a calculator. I should get something like 5,400. Okay, so the value of the mass is going to be 5,400 grams. Okay, hope that's all right. If you're not sure about any of those, if you have a look at the playlist on the channel relating to direct and inverse proportion, that will give you quite a few different examples of very similar questions. Okay, let's have a look then at the next bit. Okay, a very long question for a relatively short answer. Okay, so it says A, B, C are points on a circle, DCP is a straight line, blah, blah, tangents. Okay, so, all right, so it says Sam is trying to work out the size of angle M. Okay, so this is this angle up here. Okay, no problem, that's fine. Okay, so he puts that angle ACB is going to be 56. Okay, then he puts angles in the same segment are equal. Okay, this is your problem, and it's only a 1-mark question, but basically it's not the same segment, it's the alternate segment. Okay, so in other words, this is 56 and this is 56, so he's kind of right about that, except he's used the wrong reason. It's a bit of a strange question, really. It just says make a criticism of his working. Well, the criticism is that actually he should use the word alternate. However, the rest of his working is perfectly fine. That M is going to equal 180 degrees minus 56 because it's a straight line, angles at a point on a straight line. Yeah, I'm fine with that. So therefore M is 124. So he got the correct answer, but there's just that slight error in his reasoning. I don't know whether that's worth 1 mark, but apparently it is. Okay, so let's have a look at the next one then. Is going to be question number 23. A sequence of numbers is formed by the iterative process. Okay, work out the values of U2 and U3. All right. Okay, so again, this is iteration, which is one of the newer topics from 2016 change in curriculum. Please do have a look at the website, the channel, and there are playlists on iteration. Okay, so what we're saying is that the value of U1 is going to be 4, and we're going to use that value and basically plug it into the equation. So we can say U1 equals 4. Well, that's the information we're given. Okay, so if we want to work out the value of U2, now don't get confused by this subscript here. It basically means the next value along. So U1 plus 1 is U2. Okay, we're going to take that value of 4, and rather than putting it there, we're going to put the number 4 in place. Okay, so when we do that, we get 3/5. So the value for U2 is 3/5. And then if we work out U3, we do exactly the same thing. Now again, we're using a calculator, so it's not too bad. So we've got 3 over, and we're going to now use this value, 3/5 plus 1. Sorry about my wobbly writing there, but 3/5 plus 1, and again pop that into a calculator and you're going to get 15 over 8. Now you might be tempted with both of these to actually put them down as decimals. That's perfectly fine as well. So 3/5 is the same as 0.6, and 15 over the 8 is the same as 1.875, and that's perfectly fine. If you prefer to work in decimals, that's absolutely fine. Okay, so let's have a look at question number 24, which is a speed time graph. Okay, speed time graph shows 20 seconds of a car journey. First 20 seconds, okay. And Harry wants to estimate the distance the car travels. He uses a triangle and trapezium as shown. Okay, so complete Harry's method is A, to estimate the distance the car travels. So basically what we're doing is we're going to work out the area of the triangle and the area of the trapezium. Okay, well, the area of a triangle is going to be a half base times height, and the area of a trapezium is going to be a half a plus b times h. Okay, so let's just have a look at that. Okay, let's solve this area A. So area A is going to be a half base times height. Now some people will write the area of a triangle as base times height divided by 2. That's perfectly fine, doesn't really matter. What we're saying is the base in this particular case is 10 and the height is 20. Okay, so just concentrating on A, along to 10 and up to 20. So we can pop that in as a half. Base is 10 times 20, which is the height. That's going to give us half of 200, which is going to give us 100 meters. Okay, so that's the distance traveled in the first 10 seconds. So at this point is 100 meters. Okay, let's have a look then at B. Now, I remember this as a half A plus b times h, which is the formula for the area of a trapezium. Now, not everybody will do it like me. It might be some people kind of divide this up into a compound shape. So you've got, you know, this is A and this is B, and you can do a square or a, is that a square? No. Okay, so you can do a rectangle and then you can add on a triangle if you want to. However, I tend to use the formula, so that's going to be a half. Okay, and A is this line here and B is this line here. Okay, so you've got to kind of imagine it swiveled through 90 degrees. So A is going to be 20. okay, and B is going to be 30, and then H is the distance, the height if you like. So imagine it swiveled through 90 degrees as a normal trapezium. Okay, so the height is going to be, what have we got there, 10. Okay, so pop that into my calculator, work all of that out, and I should get 250 meters. Okay, so the height that Harry travels, the distance that the distance that Harry's car travels is going to be 350 meters in total. Okay, hope that's all right for you. Now part B is where you're asked to tick a box. Okay, it's actually this one here, and it says, for this journey, which of these is true for Harry's method? Okay, well, actually, if you look back at the calculation, he's actually working out an underestimate, because he's put a straight line here as a trapezium, but there's all this little bit here. Okay, so actually it works out as an underestimate of the distance. Okay, hope that's all right for you. Let's move on then to question number 25. So we're about 15 minutes into the video. Okay, please do stop the video, have a go at each of these questions. Okay, now this one's a bit of a long one, so this will probably be the last one maybe in this this video, I think. Okay, because we're going to be using various different skills to be able to kind of figure out different things. So the first one is going to be working out the height of CD. So actually all we're interested in is this triangle here, okay, which you'll notice is a right angle triangle. Okay, so we could, if we look at it, say, well, actually CD is the opposite. Okay, this long line here is going to be the hypotenuse, and this 500 meters is the adjacent. So I can now use one of SohCahToa to actually work out my opposite, in other words, my CD value. Now, the only two I've got a choice is this one where I need the hypotenuse, or this one where I need the adjacent. Well, I've got the adjacent, so I'm going to use this relationship. I'm going to say the tan of 6 degrees equals the opposite divided by the adjacent. Okay, so let's put some numbers into that. So I've got, if I just move it up there, I've got the tan of 6 degrees equals the opposite, which is the bit I'm interested in, divided by 500. So if I want to find out the value of the opposite, I multiply both sides by 500. So I need to calculate 500 times the tan of 6 equals the opposite, or CD. And when I pop that in my calculator, I should get 52.6 meters. All right, and that would be the answer to this particular question. Okay, hope that's all right for you. Now, the next part of this question uses exactly the same diagram, but this time Jamil walks in a straight line from A to D. Okay, must show the size of angle DAC. Okay, so let's just try to kind of figure out what's going on there. So if he's going to walk from A to D, okay, basically he's going to walk up the slope. Okay, now I know my drawing won't be great, but he's going to walk up the slope. Now, in order to walk up the slope and find out that distance, okay, we need to do just a little bit of manipulation, because what we're really interested in is the angle between DA and C, which is this bottom corner here. So it's actually this angle here that we're interested in. Okay, so hopefully that's come across okay on the video, but in order to kind of work this out, well, there's a couple of things that we know. In the previous question, we worked out that this was 52.6, so that could actually be quite useful to us. Okay, now we also know that this bottom line along here, okay, actually is the hypotenuse of a triangle. If I kind of try and draw this, Okay, it's the hypotenuse of a right angled triangle where the bottom is 400 and the side here is 500. So actually we can work out A to C by, that's the bottom line along here, by using Pythagoras in order to do that. So I'm going to call that A. I'm going to say that A squared equals B squared plus C squared, which equals 500 squared plus 400 squared. Okay, pop that into a calculator and then do the square root, and I should get A equals 640.3124. Okay, so in other words, now we've got a couple of things that we can use in order to work out the angle that we're interested in. So we know that this bottom line here is 640.3124. Okay, so let's just have a look and see if I can kind of draw that for you on a separate kind of drawing. So we've got this kind of thing going on. All right, so this is the distance that Jamil is walking. All right, here he is, he's walking up that kind of hill there. Okay, this is the angle that we're interested in. What we've kind of worked out is the bottom of this is going to be 640.3124, and in the previous question we worked out that this height is 52.6. Okay, so once again we're going to be using SohCahToa. So SohCahToa. Okay, remember it's a right angle, so we can use SohCahToa to be able to work these sorts of things out. Okay, so at this moment in time we know that the opposite is 52.6, so it's going to be either that one or that one. We know the adjacent is this one, so remember this is the opposite, this is the hypotenuse, and this is the adjacent. Okay, remember we're looking for the angle, we're not looking for the length of the hypotenuse. If we were, we could use Pythagoras again. Okay, but this particular one we're looking for the angle. So the relationship I'm going to choose is going to be this one, because I know the opposite and I know the adjacent. So I can say the tan of, let's call it x or DAC or whatever you want to call it, this is x down here, is equal to the opposite over the adjacent, which is equal to 52.6 divided by 640.3124. Okay, now remember that we're not interested in the tan of the angle, we're interested in the angle itself. So what we have to do is use our calculators, and in the calculator we're going to type tan to the -1, which is usually the shift tan key, so it's usually kind of like an orange key or something like that. And if we pop that into a calculator, okay, we're actually going to get the angle rather than the tangent, and that's going to be 4.696 degrees. So actually it's a very gentle slope. The answer to one decimal place is 4.7 degrees. Okay, hopefully that's all right. It does take a little bit of working through, but I have seen these questions before on other exam papers, so it is worthwhile getting to grips with working with these sorts of designs or these sorts of questions where you've got to use Pythagoras, then you've got to use, in this particular case, trigonometry or SohCahToa. Okay, hope it's been useful for you. Please do add a comment below if you're not sure about anything. I'll always come back to you. We're going to start with question 26, which is dealing with histograms, in the next video, which will be video number 4, and I look forward to seeing you next time.